Hello children, now we discuss about this questionnaire that is given here. First question, why should curd and sour substances not to be kept in brass and copper vessels? So any answer from your side? You think about that? Okay. So curd and sour substances contain acids, that you know, right? Curd and sour, any sour substance that we use, it contains acids such as lactic acid in curd and citric acid in the sour fruits, right? So when these acids come in contact with the brass or copper vessels, right, they react with the metal to form the toxic salts. So the acid that is present inside the sour substances that we are taking, curd or any other sour substances, the copper will react with this one, right? So the toxic compounds will be released here. So they react with the metal to form the toxic salts. So whenever the acid that is present in these substances that react with these metals, acid reaction with the metal, that forms toxic salts. So these toxic compounds are harmful to be consumed. That's why you have to be very careful whenever you are keeping any acidic type of substance in a copper vessel or metallic vessels. Try to avoid placing acidic substances inside metallic vessels. So instead of that, we can use glass kind of things, then there is no harm for that one. So you should not keep acidic substances in copper or any other metallic vessels, right? That is very, very important. We should remember that. The next one, which gas is usually liberated when an acid reacts with the metal, right? Illustrate with an example. How will you test for the presence of this gas? So here, when acid reacts with the metal, we just now observed that H2, hydrogen, will be released, right? How one example we can say, zinc and HCl, if they react with each other, zinc chloride is formed and hydrogen gas is released, is it not? So if it is balanced, we can get 2HCl plus Z10Cl to H2. How you test that? So we can do one simple experiment. We collect the gas in the test tube, bring a burning splinter close to the mouth of the test tube. If it is hydrogen gas, then it will burn with the characteristic pop sound. The pop sound will come and the gas will burn. When you hydrogen gas is present, it will burn with the characteristic of pop sound. So that is the test for hydrogen, right? Now the third question, metal compound A reacts with the dilute hydrochloric acid to produce effervescence. The gas evolved extinguishes a burning candle. Write a balanced chemical equation for the reaction if one of the compound formed is calcium chloride. So that is the thing, that is it. The gas that extinguishes a burning candle is which gas? Carbon dioxide, right? So since calcium chloride is one of the product, a metal compound A must be calcium carbonate. So they already gave the compound that is produced is which one? So so we can write like this, calcium carbonate reacting with HCl, that is giving calcium chloride plus carbon dioxide plus H2O. So here metal compound A reacts with the dilute hydrochloric acid. What is our metal compound? CaCO3, is it not? So it is acid to produce effervescence. The gas evolved extinguishes a burning candle. That gas is nothing but carbon dioxide, right? Balanced chemical equation if one of the compound formed is calcium chloride. So since it is given as calcium chloride, we need to take HCl as our acid. So this is our balanced chemical equation for the given activity. So next one, what do all acids and all bases have in common? So we are doing some observation on acids and bases in these activities. So here what we are taking, So solutions of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. we are taking, right? So fix 2 nails on a cork. Here you can observe 2 nails we are taking in a 100 ml beaker. Connect the nails to the 2 terminals of a 6-volt battery. Here we are taking 6 volts battery, right? Bulb through a bulb and a switch. Here we are having a bulb and we are using a switch also, right? Now pour some dilute hydrochloric acid in the beaker and switch on the current. We are passing current through the dilute hydrochloric acid solution, right? Repeat with dilute sulfuric acid also. What do you observe? Repeat the experiment separately with glucose and alcohol solutions. What do you observe? Now, does the bulb glow in all cases? Here, what we are doing? First we are taking hydrochloric acid, then we are taking sulfuric acid, and then we are taking the bases also. And separately each time we are conducting the same experiment. We are putting 2 nails here and we are putting a battery and bulb with a switch. So here the observation will be, whenever you take acid there will be glow. You can observe current is carried through the acidic solution, then bulb will glow, right? But if you take the base solutions, bulb won't glow. That is one test. So why it is happening is, acids are containing H plus ions as cations and anions such as Cl minus, NO3 minus in HNO3. You know the basic acids are HCl, H2SO4, HNO3 like this. If you observe in all these acids, H plus ions are present, right? And even if you take H3COOH, so what are the negative ions you observe? Cl minus in this case, and SO4 minus, right? SO4 2 minus, right? NO3 minus, like this. So the cation present in the acids is H plus, that we can observe. That is a common cation that you can observe. This suggests that acids produce hydrogen ions in solution, which are responsible for their acidic properties, right? Repeat the same activity using the alkalines such as sodium hydroxide, calcium hydroxide. So what you will conclude that they are asking. Basically the observation is, for the acids you will find that a bulb will be glowing, and for bases that won't happen. Now the next activity is very important one. What happens to acid or base in water solution? So if we add water to the acid or base, what is going to happen, that we are going to observe here. So here we are taking 1 gram of sodium chloride in clean and dry test tube and set up the apparatus as shown here. So here we have taken sodium chloride in this test tube. So concentrated sulfuric acid we are adding to this test tube, is it not? So test the gas evolved successively with dry and wet blue litmus paper. In which case does the litmus paper change color? On the basis of the above activity, what do you infer about the acidic character of dry HCl gas and HCl solution? Both the ways we need to observe, right? So if climate is very humid, you will have to pass the gas produced through a GAR tube, drying tube containing calcium chloride to dry the glass. So when moisture is present, then also you will observe some different in this activity that we will observe. So here what we did HCl, hydrogen ions in HCl are produced in the presence of water. So only in the presence of water only hydrogen ions are produced, H plus ions from HCl molecules. Cannot occur in the absence of water. If water is not present, this phenomena H plus ion won't come out actually. So here HCl plus H2O, when water is added to the acid, it is forming H3O plus and Cl minus. Hydrogen ions cannot exist alone, but they exist after combining with the water molecules. Thus hydrogen ion must always be shown as H plus aqueous form only, or hydronium ion. So H3O plus, like this only it will exist. That means H plus independently it cannot exist, only in the presence of water or humid, then only we can observe H plus. So we have seen that acids give H3 plus, H3O plus or H plus aqueous ion in water. Let us see what happens when the base is dissolved in water. Similarly, now we observed how the acid is behaving in the presence of water. Now we are doing the experiment with the base. We know NaOH is a solid, it is a base. So in the presence of water H2O, how it is going to behave? Na plus aqueous and OH minus aqueous is obtained here. So here our observation is, in the presence of water, bases, they are forming OH minus aqueous ions in water. So bases which are soluble in water are called alkalis. Bases that are soluble in the water are known as alkalis, right? So in the present, KOH is a base, it is in the solid form. MgOH twice is a solid. So in the water, presence of water, how they are producing OH minus ions, that activities are represented here. So all bases do not dissolve in water, this we need to observe. So an alkali is a base that dissolves in water. If the base is dissolved in water, it is known as alkali. All bases, they won't dissolve in the water. So whichever are dissolved in the water, they known as alkalis, and they are soapy to touch, bitter and corrosive. Never taste or touch them, as they may cause harm. So these alkalis are harmful. So that these things we observe now. So here you can observe acid and base, they can getting reacted to form salt and water. So any acid is in the form of HCl, HNO3, H2SO4 like this. It is a combination, HX we represented like this. So that we are adding with the base NaOH, CaOH, like that you are having bases. So the reaction that will generate salt and water, that is again given. So the process that we are doing, adding water to acid or base, that method is known as dissolving acid or base. So otherwise it is known as diluting. So here you can remember, mixing acid or base with the water results in decrease in the concentration of the ions. So here H3O plus or OH minus per unit volume, such a process is called dilution, and the acid or base is said to be diluted in this process. Now we observe the questionnaire here. So the first question, why do HCl and HNO3 etc. show acidic characters in aqueous solutions, while solutions of compounds like alcohol and glucose do not show acidic character? So this is the question. So here acids like HCl and HNO3 ionize completely in water to produce H plus ions, which are responsible for the acidic behavior. So HCl gives H plus Cl. Alcohols and glucose do not ionize in water to produce H plus ions. So they do not exhibit acidic properties. Even though alcohol contains OH groups, they do not dissociate like bases do, and thus alcohols do not behave as acids. That is the answer. So the next question, if you observe, so why does aqueous solution of an acid conduct electricity? So we did an activity here, acids dissociate in water to produce free ions, that we observed here. So H plus and corresponding ions like Cl minus, NO3 minus, etc. they form only in the presence of water. These free moving ions act as charge carriers, allowing the solution to conduct the electricity. So stronger acids like HCl and H2SO4 ionize completely and conduct electricity well, whereas weak acids ionize partially and conduct electricity poorly. That is your observation. Next question, why does dry HCl gas not change the color of the dry litmus paper? That is the question. So here Dry HCl gas does not contain free H plus ions. Just now we discussed here. Only in the presence of water only we can find free H plus ions, because it does not dissolve in water in the absence of the moisture. So litmus paper responds to H plus ions only. So if no water is present to help HCl to ionize, the paper remains unchanged. However, if the litmus paper is moist, HCl gas dissolved in the moisture and ionizes and turns blue litmus to red. So whether HCl should be diluted in the water or litmus paper should have the moisture, then only you can observe the change. Next question. While diluting an acid, why is it recommended that the acid should be added to water and not water to acid? Acid should be added to water and not water to the acid. Why it is? So here, adding water to a concentrated acid can cause violent exothermic reaction. Heat is released suddenly, which is dangerous. So this can lead to splashing and accidents. So instead of acid should be added slowly to water while stirring to dissipate heat gradually and ensure safety. So never add directly acid. We have to do it in a very slow manner. Next question. How is the concentration of hydronium ions affected when a solution of an acid is diluted? Dilution means, what is dilution? Adding more water, which increases the volume of the solution. So this causes the concentration of H3O plus hydronium ions to decrease, making the solution less acidic. However, the total number of H3O plus ions remain the same, but they are spread out in a larger volume in this case. Last one, sixth question. How is the concentration of hydroxide ions affected when excess base is dissolved in a solution of sodium hydroxide? So adding more NaOH, a strong base, increases the number of OH ions in the solution. This makes the solution more alkaline, right? So more alkaline means pH increases. Too much NaOH is added beyond saturation. Some may remain undissolved, but the dissolved portion will still increase the OH minus concentration. So that is the answer for this question. Thank you.